Hello, this is Ms. DB, and in this lesson we're going to discuss Chapter 7, Section 3 on how to prove that you have similar triangles. So triangle similarity. There's three ways we're going to do that with angle, angle, side, 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 and side, angle, side. So if you remember back to Chapter 4, or you can even look back in your books, we proved triangles were congruent. And we found that side, side, side was one way to show you have congruent triangles, and side angle side was a way to show you have triangles are congruent, but AA was not one of them. But it turns out that those are also can be used slightly different theorems to say that you have two similar triangles. So that's our objective for today. We'll prove triangles are similar and also use triangle similarity to solve problems. All right, so we're going to use the SSS and the SAS similarity theorems, just like the ones that we use to prove triangles congruent. So here, here's the angle-angle similarity one. All right, so this postulate says that if you have two angles of one congruent triangle congruent to two angles of another triangle, then the triangles will be similar. We don't have to know that the third ones are congruent to each other, but they would be by the third angles theorem. So really it's angle, 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 but we only need angle, angle in order to say, yep, these are similar triangles. Note the similarity symbol there. So let's see if AA works with this. We have triangle ABC and triangle DEC here, and we know that angle A is congruent to angle D because they're both right angles. Also, remember vertical angles? When you write an X, vertical angles are on the opposite side of that X. So these two angles will be congruent to each other. So let me mark those congruent, congruent, congruent. They used something different. They said because this is a right angle and this is a right angle, these two lines, no, AC is parallel to DC. Okay, so I don't know what they're exactly doing with this first part. So what we'll say is that angle BCA is congruent to angle ECD by vertical angles. I think that their instructions go with a different problem. Vertical angles. The vertical angles theorem says these are equal to each other, congruent to each other. Also, angle A is congruent to angle D because they're both right angles. So therefore, they are similar to each other by angle, angle, AA. Similarity postulate is the whole thing, but okay. Also, then you're supposed to write a similarity statement. Hey, they didn't do their similarity statement. Oh yeah, they did right here. Triangle ABC is similar to triangle DEC. So A and D are both the right angles. B is the angle we don't know, and E is the angle we don't know. And then C and C, those are the vertical angles. Okay, explain why the triangles are similar and write a similarity statement. So I'm not sure if they got this right or not, but let's see. We've got that angle B is congruent to angle E, both right angles. We don't know what this angle is, so let's find it. We can take 180 minus 43. Oh, let's do 180 minus 90 instead of 180, let's do 90. Because I already took 180 minus 90 is 90. So 90 minus 43 is 47. So this angle here is 47 degrees. So this angle, angle C, is congruent to angle F. So angle C is congruent to angle F. Angle B is congruent to angle E. And that's all we need to know. We've got AA. Then you have to write your, this is your similarity statement. Triangle ABC is congruent to triangle D, that would be the 43. E, these two are both the 90s, and then C and F are both the 47 degrees. So you have to make sure you put these in the right order or it's wrong. Okay, here's another postulate, or theorem. This one's a theorem. Side, side, side. Now, it's not that if three sides are congruent to three sides, it's if they are proportional. In other words, if you write them as ratios, if you have the same similarity ratio for each of them, then you have similar triangles. We already used this in the last lesson. We just didn't call it side, side, side. Also, we can do side, angle, side. That means if you know angle B is congruent to angle E, and side AB over DE is the same ratio as side BC over EF, then you have similar triangles. So we'll use those in some problems here. All right, we got to verify that these triangles are similar. So we don't have any angles given, so we must try to use side, side, side. Now remember, we don't have to say they're congruent to each other, we have to say they have the same proportion. So the smallest one here is 2, and the smallest one in the other triangle is 3. Let's write that as a ratio, 2 to 3. Now that has to be the same ratio as the other sides, 3 over 4.5, and the other one would be 3 over 4.5. It's very difficult to tell when you have a decimal if that's the same as 2/3. Let's change these to percents. This would be 0.6666666666. Change this to a decimal. Okay. When I do this, it's going to go out of the thing for a minute. So let me pull my calculator up. 3 divided by 4.5 is 0.66666. Same thing, see? 2 divided by 3. So that's one way to check if you have the same similarity ratio, is you can change them to decimals. So since both of these were able to be written as the same decimal, then you know that they are similar. And they are similar by side, side, side. All right, then here's another example. Now this time we are given this angle is 70 degrees, and so is this one. So we know that angle D is similar, or actually it's congruent to angle H. Okay, check. Now we don't have another angle, so we can't use this. We don't have enough sides, so we can't use this. We have to try to use this. The angle has to be between the two sides, the ratios. Is it? 5.8 and 2, 2.9 and 1. Yes. So now we can check the similarity ratios and see. Let's do DE over JH first. That would be 2 over 1. That simplifies to 2. Now remember to go in the same order. I took the big triangle first, so I'm going to go DF over HK or KH. And that would be 5.8 over 2.9. And then you need to use your calculator and see if 5.8 divided by 2.9 is 2. And since it is, then we know that these two triangles are similar by SAS. The little symbol after the SAS is the short way of saying the side angle side similarity theorem. So you don't get confused with side angle side congruence theorem that we used in chapter 4. All right, we want to do a practice problem here. Think about whether we would use angle angle, side side side, or side angle side. No angles are marked congruent right now. Do we know any theorems from chapters 1 through 6 that would let us find that we have congruent angles? Vertical angles right here. So it looks like we're going to be using this one. So notice that you do not put the 12 with the 20. You put the 12 with the 16 and the 15 with the 20. We want to see if these simplify to the same ratio. So if you simplify 12 over 16, divide them both by 4, you would get 3/4. Divide by 4, divide by 4. If you simplify this one, you would divide them both by 5. You're also going to get 3/4. So we've got an angle. We've got two sides. They both simplify to the same similarity ratio. So therefore, by SAS similarity theorem, these two triangles are congruent. Triangle TXU is similar to triangle VXW. Now in this one, the two triangles are overlapping. It can be very helpful to redraw the triangles so that they're not overlapping. We clearly have one triangle bigger than the other one. I'm going to line them up so that the right angles are kind of both in the bottom right. This littler triangle is 9 by 5. We don't know this side. The bigger triangle is x for the height and 9 plus 3, or 12. So we've got angle, angle. Now we need to see what it says, explain why they are similar and then find CD. We also know that this angle is congruent to this angle because they're the same angle. Those two triangles are on top of each other, so those two angles are the same by the reflexive property. So we have angle, 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 angle. So I'm actually using this one. So the two triangles are similar by angle, angle. Once you know that they are similar, then you can set up a proportion to solve for the missing side. I'm going to do it on this page. So I would do the leg on the bottom over the leg of the other one. This is one way to set your proportion up. And that would be equal to the height over the height, 5 over x. And then we would solve that proportion. Product of the extremes equals the products of the means. And 9x equals 60. And we would find x. It's going to be a decimal number. I could divide both of these by 3, and I would get 20/3, 6 point something. Let's see what they get. Six and 2/3, or 6.666. Okay, this is similar. A similar triangle problem. We have a little one and a big one, and they're overlapping. Now this time we are only given RS. We're not given this little piece from here to here. So again, you can draw the two triangles separately if it helps you. We know that the two triangles are going to be similar because, again, of angle, angle. This angle R is the same in both of them, so by the reflexive property. S and T are congruent to each other because that's given, it's marked. Okay, so these are like little mini proofs, but you don't have to do a 2-column proof. Then, because we know that the two triangles are congruent by angle, angle similarity postulate, now we can set up a proportion. And I don't like that they put the proportion without the figure. So I'm going to do this side 1/8 of the short one over 12. That would be equal to the other side of this smaller triangle would be 10. And I don't know this part here. That's my unknown. That's what I'm trying to find, RT. So I would solve this. So 120 equals 8x. And then you would find that would be what RT would be equal to. So 15. So x equals 15, and that is actually what RT is. So I could have used RT instead of the x, but I don't like to use 2 letters when I'm solving an equation. I'd prefer to just stick an x in there. This is just the work that I just did, so I'm flipping through it quickly. They used RT, see. Okay, here's an actual proof with the steps and reasons. All right, there's, I think, one of these on your worksheet, and it's a short one. All right, so we are given, let's see, here's UT. This, 3 of these equals 5 of these. And 3 of these equals 5 of these. Okay, we are supposed to prove that triangle UVT is similar to triangle RST. Well, we're going to use one of these methods. Right away, I would say, oh, look, we've got vertical angles. That's going to certainly be something we're going to use. So we're going to start with the given statements. And then remember in the last section, we wrote similarity ratios by dividing. So if I wanted to change this to UT over RT, I had to divide both sides by 3RT. And when I do that, I get UT over RT equals 5/3. So that's my similarity ratio. That's going to be helpful. We also were given this, and we're going to do the exact same thing, except we're going to divide both sides by 3ST. And when we do that, we get VT over ST equals 5/3. They both have the same similarity ratio. We also, there's the angles. We knew that those two angles were congruent by the vertical angles theorem. So that means that these two triangles are similar by SAS. The sides were in the same similarity ratio. They're proportional. And the angles in between them were congruent. Now, note that we did not write angle T is congruent to angle T. You have to use the letters. T will be the middle of both of them, but you have to put the 3 letters to name the angles. Okay, here's another one. M is the midpoint. As soon as I know that M is the midpoint, I'm going to be like, oh, well, that means something. It means that this will be congruent to this. That might be important. N is the midpoint of KL, which means this side is congruent to this side. And P is the midpoint over here, which means that these two sides are congruent. All right, so let's see, what do we got? We've got that all the givens are written down. That means that MP, see MP, is half as long as KL. That was the mid-segment theorem from last chapter. We learned that this mid-segment right here will be half as long as KL, the side it's parallel to, and parallel. The parallel part doesn't matter. So I can mark this with that same thing. We also know that MN will be half as long as JL, and that NP will be half as long as KJ. Look at all, you've got 4 little congruent triangles in there. Isn't that nice? All right, we are trying to prove what? I didn't write what we were going to try to prove here. Sorry about that. That means I just divided both sides by KL, and I got MP over KL is 1/2, MN over JL is 1/2, and NP over KJ is 1/2. I think we're trying to say that this little triangle is similar to the big triangle. Yeah, triangle JKL is similar to triangle NPM by side, side, side. All 3 sides were in proportion to each other because they all simplified to the same similarity theorem. I mean, similarity ratio of 1/2, 1 to 2. All right, there are just a few other things that we need to go over. We're not going to really use them in a problem yet, but we will as we continue. The reflexive, symmetric, and transitive properties also hold true for similarity of triangles. So the reflexive property says that triangle ABC is similar to itself. Okay. Also, if triangle ABC is similar to triangle DEF, then DEF is similar to ABC. That makes sense, right? If one triangle is if you say the little triangle is similar to the big one's also similar to the little one. Also, transitive works. If ABC is similar to DEF, and DEF is similar to XYZ, then you could just go that ABC is similar to XYZ. You can jump over the middle part. So those properties that we learned about in Chapter 2 for congruence also work for similarity. All right, that's it. So have a good time doing this worksheet. Good luck, and let me know if you have any questions. Thank you.